Hello everyone, this is Bronson. Do you see any differences between the two batteries I'm holding? Right, one is from Electric, the other one is made by myself. Today I'll show you how I made mine. If you have been following my channel, you know I have made lots of upgrades for my e-bike. Among all the upgrades I have made, the one I have been wanting to tackle has always been the battery upgrade. The battery for electric e-bike is removable, so the easiest way to upgrade is to buy one from the factory. But Electric made a change recently. They started using batteries other than Samsung and LG, so I decided to make my own e-bike battery. I was able to quickly find empty cases of this e-bike battery on the internet, and they arrived quickly after I made payment online. I plan to make two batteries, one for me, one for my wife's e-bike. I was also lucky enough to find 18650 battery cells online. These second-hand battery cells are very cheap, but require some elbow grease to make work. How to take these battery cells out of the plastic boxes? This is what I did. First, cut the label with a knife. Then, use a side cutter to cut open the outer shell. Cut, then twist. This is the easiest way I found. Repeat until all battery cells are removed. During this process, I found there are different brands of battery cells from the ones I bought. The green ones are from Sony, the blue ones are from Samsung. The small BMS here is useless, so remove them all with scissors. After the process, the battery now looks like this. Now put all the battery cells neatly on the side. Be careful not to short-circuit the batteries. Then measure the voltage of these batteries one by one. The voltage of these batteries should generally be around 3.6 volt or above. Dispose the cells that have too low voltage, because those cells were not protected properly and won't be useful. The order of my battery charger got delayed, so I used some charger circuit boards, made quite a few battery chargers myself. To use this circuit board cannot be more simpler. Just connect it to two wires and two springs. Then plug in the mini USB power cable and good to go. When charging, the red light is displayed. When fully charged, the blue light is on. Of course, the polarity of the battery cannot be reversed, otherwise it will heat up and burn. It even has the potential to explode, so be very careful. So don't say I didn't warn you. Please do not do this at home. DIY projects of lithium batteries are generally not easy to do and can be risky. Make sure to thoroughly do your homework and research before you even consider attempting for yourself. Getting back to the project, after organizing these battery cells, I charge them first. During the charging process, I carefully observe and measure their temperature and voltage and their charging time. From that, I have a preliminary judgment on the health of these battery cells. Based on what I got with these battery cells, I also finished the preliminary design of my e-bike battery. My video today mainly uses this Samsung 24E battery. According to the spec sheet, the capacity of this battery is 2400 mAh. Its maximum discharge current is 4800 mA, so the batteries I'm using today are so-called modern batteries. But this particular model is good enough for my e-bike. Let's make a simple calculation. My e-bike controller current limit is 18 amps. The voltage of the battery for the electric e-bike I'm going to make is 48 volts. It is 13 serial by 4 parallel, total 52 battery cells. And the maximum discharge current this battery pack can provide is 19.2 amps. It is slightly larger than what an e-bike controller needs. The capacity of a finished battery pack will be 9.6 amp hours, and that is about 460 watt hours. Because the battery case of this particular e-bike is very narrow, so 52 batteries need to be placed like this, with a tiny BMS on the top. I first started with charging the battery to about 4 volts. Then I measured voltage on them one by one. According to the voltage level, I put them into different groups, 4 in each group. In the same group, make sure their voltages are close. Every 4 batteries will be directly connected in parallel. If voltage differ too much, when they are connected in parallel, they may charge each other and cause heat. I got lucky again. I found a small box like this. 16 battery cells are perfectly fit inside this plastic box. It saves me a lot of headache. Otherwise, I have to make a battery holder. So my motto is be creative, be resourceful. With these things ready, now is welding time. Considering the current on each battery is about 5 amps, so my nickel strip is 0.15 by 8 millimeters. After cutting this nickel strip to the required length, then cut them into rounded corners. Because sharp corners are easy to discharge, easy to puncture insulation and the fingers. Finally, it's time to take out my spot welder to start welding. In my previous videos, I have introduced the use of this spot welding machine to you. It's almost impossible to do such a project without such a machine. I put 4 to 6 spot welds on each terminal. It is relatively easy to weld a negative terminal, but be careful for the positive terminals. Make sure the welding spots are within the positive terminal cap. That is the center part of positive side of the battery. The second-hand batteries I got this time are still pretty good. Its biggest advantage is that it's cheap. The second is that itself has connected both batteries together. It also saved me a lot of work. I often put the nickel strip by hand to ensure that each welding spot is very firmly welded. After welding the 8 batteries together, I measured the total voltage again. The voltage of 2 sets of batteries are both about 4.13 volts, and temperature is normal. Then open them up like this. Then repeat the process. Then we'll get the batteries like this. The next step is to prepare some short nickel strips. Also trim the sharp corners. We need a lot of them. The top part of battery need to be put like this. The last 4 batteries need to be put into a very awkward position like this. The reason why the battery had to be put into this way is because the battery case is very narrow and long. Now the top part of the battery are welded together. I fix them with insulating paper and heat-resistant tape right now. When the insulation of each component is well done and strong, the whole battery pack is safe and sturdy. What's next? Next step is to glue the insulating plate to the one side of the battery. By using this insulation plates, it's ensured that there will be no physical contact for the adjacent batteries with different voltages. Installation of e-bike batteries must be handled with great care, because when riding an e-bike, it's constantly bumping and shaking. The insulation layer can be easily damaged if the battery pack wasn't made properly. Normally, resin epoxy boards are used for insulation between adjacent cells. But the insulation board I'm using this time are the ones that came from the battery that I bought. The result is pretty good. Now the battery pack becomes quite big. They cannot fit in the small plastic box that I found. I have to fix them with tape and small wooden boards. Try to fix them tight and neat. Each row must be aligned properly. For the other side of the batteries, also use tape to fix the insulation boards, to make sure there's no physical contact between batteries. I did all the parts so carefully, and I believe all the hard work will be paid off. Then weld them together with the nickel strips. Lots of short nickel strips are needed at this time. Normally, we should use those white nickel strips, known as 2P nickel strips, at this time. That could be more convenient. But for this kind of batteries that I bought, most of them are already connected in pairs. When I opened their plastic shells, I didn't separate them, and now they can still stay together. Then I don't need 2P nickel strips this time. Now is fix the other row, and repeat the process. After welding them together, the battery pack now looks like this. Then untie them and put these two rows of batteries straight. At this time, I use this plastic tool to push the middle of the short nickel strip to ensure the nickel strip will be folded in the middle. So the batteries will be opened as the way you want to be. And sure enough, they look straight. Then do the same and open the other side. I paid a lot of attention when doing this type of work. All these batteries are charged. There have never been a switch that can turn off the power to these batteries. In other words, they are always on. So whenever I see exposed wires, I always use a tape to cover it. That is why you often see so many black tapes on my semi-finished battery packs. It's a good way to minimize the possibility of a short circuit accident. Whenever I see metal on the side of the battery pack, I cover it right away. And I frequently measure the battery voltage levels and battery temperatures to ensure that all connections are correct. If there are any wrong connections, they can be found right away. Hopefully, it's not too late. But it is really a good way to confirm the connections are correct. This part is very similar with the previous part. The only difference is that there is a connection to the top row of the batteries. It's right here. This is what it looks like after welding. Now untie and open the batteries. When I arranged to weld the nickel strips, I paid lots of attention to the direction. When welding in this direction, after folding, all exposed nickel strips are facing outside. This reduces the risk of nickel strip forming a short circuit from the inside. When nickel strip facing outward, the insulation is very easy to handle. Now I'm welding these two parts of battery together. The current passing through this point is relatively large. So I put 2 layers of nickel strips here. It will generate less heat this way when huge current passing by. Now I'm welding the last 2 batteries on the top. Finally, All the welding work is completed. 52 battery cells were welded together. It looks very solid. By now, I got a small sense of achievement. Now I take out my soldering oil and iron and start soldering the connections. Because the special arrangement of this battery pack, I need to use lots of jumper wires to connect them together. This battery is 13S by 4P, so there will be 14 connections to the BMS. So I made 13 labels taped next to the soldering point. This makes my wiring and soldering job easier. Put these 13 labels close to the positive terminal of each batteries, plus the negative terminal of the first battery. The total will be 14 connections to the BMS. Number 13 is the positive terminal of the last battery. This is the BMS I used for this battery pack. It's very tiny and with a temperature sensor. Connection wires are long enough. This is the lock inside the battery case. It's also the on-off switch for the e-bike. And this is the general connector and the charging port. All these parts need to be installed inside the top of this battery case. Inside of this battery case is very narrow. This is the only way to put 52 battery cells inside this battery case. The tiny BMS fits in perfectly. This is the spec sheet for the BMS and a wiring diagram. According to the diagram, I started the wiring work. Sure enough, there are 14 wires come out of the BMS. The first wire color is black. Connect this to the first battery's negative terminal. The last wire color is red. Connect this one to the last positive terminal. When laying out the wiring, be sure to be clear and tidy. It is not just about keeping the things pretty, also for the performance and the safety considerations. I also cut some barley paper, stick them in between the cable wires and the batteries. The barley paper is a pure cellulose, so it's good insulation. Then I soldered the connection wires one by one, according its numbers. Make sure to unplug the connection wires out of the BMS when soldering. Otherwise, one wrong connection will damage the BMS or the battery pack. When soldering, make sure to do it quick. Sometimes you need to put an insulation paper between the soldering point and the battery, so as not to damage the plastic wrap of the battery cells. After all the soldering work done, I check the voltages of each group of batteries from this connector. The voltage between each wires is about 4 volts. The total voltage of this battery pack is about 53 volts. Now I know the connection to the BMS are correct. The special design of this battery pack makes the negative terminal far away from the BMS, so I had to extend the negative connection wires from the BMS. Since this BMS and my e-bike are both using very thin wires to make their connections, there is no point for me to use very thick wires. I'm using 14-gauge wires for all the connections. Some metal surfaces are too smooth. I file it with a file first, so they become very easy to solder. Then I secure the charging port and fix the lock with 2 screws. Now all the connections are done. The edge of the box is very sharp. I also use a file to round it up. Then put the whole battery pack inside the battery case. Now it looks almost no difference with the batteries from the factory. I couldn't wait to measure the voltage. 0 volt. What's wrong? It's locked. 53 volts. Now I can put the battery on the e-bike and try it out. I brought both battery and e-bike outside the house to give a try. Remove the electric battery and look at them side by side. They look very similar and feel very similar with similar weight. I was getting excited and pushed my battery in. Unfold the battery and turn on the power. The display is normal. It shows 53.3 volts, similar with what I measured. After making sure all displays are correct, I set the e-bike to PAS1. Then I turned a little bit throttle. The wheel started spinning. I didn't feel any difference between electric batteries and mine. It's time to take a ride. I was very careful for the first test ride. I tried not to use too much power. Once again, I couldn't tell any difference from using the batteries from the factory. Then, I set to PAS2. I tried to maintain the maximum current below 10 amps. I rode about 1 kilometer. When I got back home, I took the battery off the e-bike right away. I wanted to check the battery's temperature right away. The battery's temperature was quite normal. It was cool. When I knew the battery wasn't heat up, I became more confident. I took the e-bike out again, and I started using the battery as usual. After about 1 hour, I finally saw some voltage drops. As soon as I got home again, I measured the voltage of the e-bike battery. The voltage had dropped from 53 volts to 50 volts. Quickly, I opened the case and took out the battery pack. I want to examine the batteries again. The battery pack fits very well inside the battery case. Those battery cells look normal after initial use. I didn't feel any heat-ups using my hands. Then I checked again with a thermometer. I didn't see any hot spots, especially for those bottleneck locations. Temperature is around 20 degrees evenly throughout the battery pack. It's just a little bit higher than outside temperature. Then I opened all the BMS connections again. I measured voltage changes of all groups of battery cells and recorded all the numbers on a piece of paper. Voltages of all batteries dropped to about 3.8 volts, which is very consistent. Then I tried to charge the battery pack. The charger, I just used the original charger of the electric e-bike. It should be interchangeable. The green light is on when not charging. When plugged in to start charging, the light turns red. I waited until next morning to charge the battery so I can observe the whole charging process. I kept checking its voltage for each battery cells and their temperatures. I want to make sure the voltage of each battery cells raise or drop evenly when charging or discharging. If a group battery's voltage raise or drop way faster than the others, then there might be at least one bad battery within that group. Temperature measurement is also very important. If the voltage rises evenly during charging and temperature does not rise significantly, these batteries are charged normally, and it also proves that the BMS is working normally. During the whole process, I constantly monitor the change of its temperature. The temperature of the charger is 38 degrees, is also a normal temperature. After a few hours, the battery was fully charged. The BMS had stopped charging. The green light is on. Then I measured all voltages one more time. The consistency of these batteries is very good. Finally, wrap the battery pack with a heat shrink film. Then put back into the battery case. At this point, DIY e-bike battery is done. Thank you for watching. Please comment, like, and subscribe. See you next time.